All right, so who can tell me from yesterday what the formula is for a growth exponential function? Reggie.
Y equals A times 1 plus R. No, yeah. Times a or
To the
T.
Yes, good. Take a point. All right, so, and we wrote down our initial amount. That's what we plug in for A. Our decimal is what we plug in for R. And what goes in T?
El año.
Yes, the time, the number of years. All right, what's our initial amount for frogs here? 100. And what is our decimal that we're going to plug in? 0.22. And after how many years are we looking at these frogs? Good. All right, and then we had 1.22 to the fifth. Now, Miss Mercer, sorry, I thought that you had my notebook and blamed it on you that we couldn't start, but really I had my notebook in my bag, so my fault, sorry. All right, so, yes, see, I remember you talking, I'm just losing my mind. All right, who can tell me how we plug it into the calculator? Nope. What's the first thing we do, Natalie? Nope.
I got you.
Reggie.
You type in 1.22.
1.22
Hit that little, what is it called?
Caret.
To
to the,
the
and then I hit equals. And then what do I multiply that by? Times 100. Now, why is our answer not 270.3 frogs? You can't have half a frog or a decimal version of frog, so you round it to the whole number. Yes, no, maybe so. Now, everybody should have a calculator in front of them because it's math class and we're using our calculators. If you need to get one, go get one quickly. Yes? We didn't round either.
I did a decimal.
You should not have a decimal because you can't have 0.2 frogs. Yeah. You could do your homework on your own.
I needed help because I forgot how to do it.
But it's still not Miss Brewster's fault, Tater Tot. Alright, so let's look at the back. This growth function, it says the population of Austin grows at a rate of 5% per year. So our growth is 5%. What is 5% in a decimal form?
0.05.
0.05. Awesome. What's our initial amount in 2010?
500,000.
500,000. So if you needed to write those down, could you have written those down?
Yes.
Yes, fantastic. And then our formula is A times 1 plus R to the T power.
Yes.
I can't wait for this.
It's Friday.
Oh, wait for this. I can't wait. Oh.
All right. And then we plug it in. So we plug in 500,000. 1 plus 0.05. And how many years is it from 2010 to 2017? Look at y'all go. Good job, guys.
No, thank you.
Did you do your homework?
No.
No? Okay. All right, so then what is 1 plus 0.05?
1.05.
1.05. And how do I plug that into the calculator?
1.05 caret 7.
Caret 7. So I want everybody to do that in their calculator right now. 1.05 caret 7.
$1.4 times 500,000.
And then 7. Good.
703,500.
All right, now multiply that times 500,000.
And you get 703,550.
70 million.
Now, it's people. Can you have 0.2 people? No. And you can't round up because it's people. We can't just create a person out of a half. That's not how it works.
On that last zero, I added 0.2.
I will not count off this time, but next time I will.
Okay.
Okay? Because it's people, right? You can't have 0.2 people.
Can't have
All right. Number 7. This is a great problem.
Great.
Great. Now, it's this exact same formula right here, but what is our initial, what are we trying to get to?
1 million.
1 million.
Oh, this one works too?
So,
Yeah.
yes.
Since it was hard to say.
Yes. But it's okay because we're going to do it together. So, you should have 1 million equal to 500,000 times 1 plus 0.05 to the x power, or the t power, or something. Because we're trying to figure out how many years, right? And years is our exponent. So we don't have an exponent yet. Is everybody with me so far?
Yes.
Alright, so then you have this right here. 1.05 to the x power. Now, how would we get rid of that 500,000 out front? What would we do? You would divide. Awesome. So you would do 1 million divided by 500,000. And tell me what you get.
2.
You do get 2. Awesome. So you have 2 equal to 1.05 to the x power.
Now that's a regular.
It is. And now we're just going to plug in and try and figure out what x could be. Okay? So we need to figure out how many years are going to pass for us to get 2. That's what we're trying to do. Now, we know that when we raise it to the 7th power, we got like 1.7 something, right? So we need to go higher than 7. Pick a number higher than 7.
14.
Okay? So let's do 1.05 to the 14th power. Everybody type that into your calculator. 1.05 caret 14. And remember, we're just picking numbers to plug in, and we chose 14. 1.9799999. Is that quite 2? No, not yet. Not quite. So, if 14 gives us almost 2, could we go bigger? Alright, let's try 15. 1.05 caret 15.
That gives you 2.
That gives you over 2. So it's between 14 and 15 years, right? Right. So we could say 2010, which was the beginning, plus 14 would give us what year? Oh my gosh, y'all. The starting year is 2010. And we're adding 14 years to it. So what year is that going to be?
2024.
So it's between 2024 and 2025. We are so, oh my gosh. I hope so. I hope that's what happens to all of you. I hope you move on to someone else and I don't have to see you again. Just kidding.
You're going to see us
Hey, every day we
maybe
go to
at
school,
one
you see us
point.
No.
I mean, you're going to see us.
Alright, now let's look at number 9. Number 9 is a super deadly strain of bacteria that's causing the zombie population to double every 2 days. Right? So, do we know the formula when zombies double every day? Didn't we do that the other day?
Yeah.
And what was it? It was something to the x power.
2.
It was 2 to the x. Good, take a point. So you should start off with 25 times 2 to the x. Now, where did I get this 25 from?
Right there, 25 cents.
Because it starts with 25 zombies. Good, take a point. Now, it says after how many days will there be 25,600 zombies? So, I set 25,600 zombies equal to this. I do divide by 25. So divide by 25 and tell me what you get.
Oh, you really want to see
Yeah, I really want you to do the math. It's crazy that in math class I really want you to do the math. Yes. Okay. Now, does it double every day or every 2 days? Every 2 days. So that's going to be important. But I want you to tell me, what exponent do you think we need?
10.
Yes. Now, every 2 days would mean it would mean 10 days would get. Oh God, that was loud today for some reason, and it scared me. So 10 days get us the zombies. Dun 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 dun. Yeah.
You're welcome.
Thank you. All right. So, are you ready for decay?
No.
Yes.
¿Por qué no?
I don't think it's work.
No entiendo. Which part?
Dude, there's just one.
He is.
Look at him.
5. That's 5.
Please answer. Tell me right now. Is it gonna be hard?
I think I know.
Is the cake gonna be hard?
No, it's the same thing. You just subtract.
Oh.
Yeah. All right. So. Oh, thanks. All right. So we're waiting on Ever to do his push-ups, and then we're gonna do decay.
A mí mismo.
A mí mismo.
Me toca.
A los dos.
All right. I gotta turn this back here on.
A los dos.
Ah, viene otra.
Oye, a mí la otra está
Alright, so open your notes to decay. Yesterday was exponential growth, which means that it gets bigger and we add. So today is decay. It is, and we're going to subtract. So if an exponential growth increases, what does a decay do?
It decreases.
It decreases. Good job. By the same what? What does it decrease by?
By the same.
Starts with an R.
Same.
What did we write right here?
Rate.
Okay, so it's by the same rate. And what letter represents rate?
R.
Good. In each time period, what?
T.
T. If you're going to keep talking while I have this class, you're going to have to sit out in the hallway. Thank you so much. Okay, then go sit out in the hallway. Alright, so Y is our what?
Final now.
Look at you go. Take a point. Alright, and what is A?
Original amount.
Good. R is your rate. And rate is usually a percent, right? But how do we plug it in as A? Good. Take a point, guys. And what is T? What's time? Oh, thank you.
Raspberry.
Hey,
I hear a train.
thank you.
Just wanted to point that out.
Thank you. All right. So now we're going to talk about how we work out exponential decay problems. This one says that the population of white tigers is decreasing at a rate of 4.5% each year. That means that they're dying, right?
Yes.
Okay? Or being hunted and slaughtered by people. All right, there are, this should be R. That drives me crazy. Correct English, people. There are currently 200 white tigers in the world. How many will be left in 11 years, assuming that they cannot reproduce? So, let's plug it into our formula. What is our initial amount? What is it? Let me finish the question. 200. Now, what is the difference between an exponential growth formula and a decay formula? One is a subtraction, one is an addition. Good job. Take a point, y'all. So we're going to do 1 minus. Now, what's our decimal for 4.5%?
0.45.
It's 0.045. So we need to make sure we're careful on that. Remember, you're moving it 2 places to the left. 2 places to the left. And how many years are passing? 11. Good. Now, are you going to add 1 and 0.045 or subtract? Subtract. All right, so take your calculators and subtract it.
I got the answer.
Tell me.
I can't tell you right now.
Okay.
Hey,
Let it go, Bielsa.
don't question me.
Yes.
0.955.
Good. Take a point.
Still mine.
All right. Now, how do we plug that into our calculator?
Oh,
0.955. And then?
Carry 11 equals.
Okay. Now, what do I do from there? Times 200. Yes. Now, is it 120.5?
No, you can't have 120.5 on type.
Because you can't have a half a tiger, right? So how many tigers are we going to have? 120 tigers.
You're so smart.
No.
Y'all are doing awesome.
Are we the best class on your team?
No.
Yes.
I think we.
If that makes you sleep at night, you can tell yourself that.
Did you know, since we're talking about tigers about to be going extinct, did you actually know hedgehogs are about to go extinct in the UK?
Yes.
I didn't know what happened with
Hedgehogs are going extinct in the United Kingdom.
I said this class last year was so good.
All right, homework sheet.
I love this class.
Homework sheet. You love this class this year, don't I? Homework sheet. So we're going to work out the decay problems on here, and then we're going to turn it into the tray. So let's do number 2 together, and then you're on your own to finish it and put it in the tray. Okay? Number 2, it says that Mr. MD is losing 20% of his hair. If he currently has 1,546 hairs on his head, about how many hairs will he have left after 10 years? Whew. Is it 0? No. All right, what's our initial amount?
1,546.
Okay? What's our percent that it's decreasing?
0.020.
It's 20%, but then we move it 2 decimal places, so it's 0.20. Okay? Now, are we going to use the same function as we did on growth, or are we going to subtract? We're subtracting. Ah. Olivia. All right, are we ready?
I'm ready.
Okay, so what is our initial amount that we're plugging in?
1,546.
1,546.
Okay, and then 1 minus what?
1 minus 0.20.
After how many years, Tater Tots? 10 years. Good.
1 minus 0.20. You gotta do all that. Yeah.
Hey, Damien, we're having a class
Okay.
where we're going over our homework and working on problems. You should get this worksheet out because it's due in a few minutes. Maybe wake up. If you need to stand up, we can arrange that. All right, so what's 1 minus 0.20?
0.8.
Good. Okay, now plug into your calculator. Do it without me. And then multiply it by?
1,546.
And you get
See?
106.
Wait, let's let everybody finish. Just breathe. Breathe. No. Why?
Why?
Is
Nick sick? Is he okay?
Yeah, just wondering about that too. He had about 30
Okay.
lots. 2 restaurants.
Be safe. Make good choices.
He had about 30 lots, 2 restaurants.
He's like, I take 2 breaks.
What are you doing? You could pay attention. All right. So did you get 166 hairs?
Yep.
Yeah.
That's not a lot of hairs on his chinny chin chin.
I don't have no hair on my cheeks. Especially if he does something on his
I see that. Please stop making that face.
like that soccer player. I forgot his name.
Which one?
He was retired. He used to have a hair like, no, like this. He had no hair. He had only hair right here.
Oh.
Why didn't you just tell us this yesterday? Like, just
I forgot
try.
his name.
I didn't even all.
Alright, so go to the back. Workout number 5 and 8. Try 10 if you want, but if it gets too complicated, you're done. Compound interest. And then we're going to fill in our cute little Venn diagram down there. So, compound interest is...
Not hard.
No, it's not. And it's usually what banks do or loans do whenever you're finding interest rates.
Money?
Yep, has a lot to do with money. So, everybody, please have your notebook open to this page. Open to compound interest. Alright, so compound interest is interest earned or paid on both the principal
Oh, I think I got the next one.
and previously earned interest. Alright, so this is what happens whenever you have a mortgage or if you have a compound interest savings account. This is the great stuff that happens to it. We're going to learn how to work it out. So, okay, can y'all be quiet? Because I'm trying to teach. A is our final amount or our balance, our final balance. So P is our principal or original.
Thank you.
R is the annual interest. Rate. Number of times, this is N, number of times interest is compounded. And what do you think T is? Time. Okay, are we ready to plug it in?
Yeah.
It seems like a lot, but it's really not. Are you ready to come back in now? Can you be quiet? Look at you go. Alright, so this says that after you graduate college, your student loans have a total of $30,000. If the interest rate of 6.8% is compounded monthly, how much will you owe 5 years if you do not pay anything? How many months are in a year?
12.
12 months. Okay, we should know that without hesitating. So let's try again. How many months are in a year?
12.
Look at us go.
Who said? Why did you say 6?
Alright, so we're going to say A equals. Now, how much are we starting with on our student loans?
30,000.
30,000. So that's what we're going to plug in right here for P. Okay? So that's our P, our original amount. We're going to plug in 30,000.
Wait, so all this is going to be on access?
Probably just growth and decay
Thank you.
and exponential functions that we did the other day. You're going to get a study guide tomorrow, as well as a notebook check.
Okay.
Alright, so then 1 plus, what's our rate? It was 6.8%, right? What's that in decimal form?
0.8.
No,
0.06.
0.068. 0.068 divided by N. What does N stand for? Read it on the paper.
Number of times.
The interest is compounded, right? And it says that it's compounded monthly. So how many times is it compounded in a year? 12. Is everybody with me so far on where we plug this in? Alright, now what goes in this N up here? It's the same thing, right? So 12. And then what's T? How many years? 5. Ready to plug it in our calculator?
Yeah.
Alright, so Rebecca is going to start and help us, and she's going to do 0.068 divided by 12, and she's not going to look at me like that ever again. 0.068 divided by 12. I just need you to do the fraction for me. Yeah, now add 1 to it. $1.056. Okay, so we're going to do 1.0567. All right, Reggie, can you use your, take a point. Can you use your calculator, Reggie, and tell me what 12 times 5 is? 60. Look at you go. All right, guys, how are you going to plug this into your calculator?
1.0567
Caret 60. All right, do that. 1.0567 caret 60. And then multiply it by 30,000. What's the final answer? Mm-mm. It's what?
Same number.
How about I just look?
Okay. Don't stress me.
Answer is 1,100. I thought this.
30,000? It should not be that much.
This has to be.
Here's 8 divided by 12. Guys, hold on. There's 2 zeros there. There's 2 zeros right here. Add another 0. 1.00. That's the problem. Yeah, it should be 2 zeros. Right? Okay, so let's start over. Is everybody ready? It's 0.068 divided by 12. So everybody get this part. We're just doing this together. I want everybody to type this into their calculator. Now, what do you do from here? No. Add 1. Did everybody add 1 and get this? Okay, now hit the caret button. And what number do we plug in? 60. Caret 60. And now what are we going to multiply that by? 30,000. That's better.
I did something way totally different.
It's because we didn't have that 0.
No, I still got the same answer.
Oh, good. 108. I think there's only like 2 of those on your homework, so don't worry. So that's how much you're going to pay back in student loans if you have a compound interest. Make sure you're paying attention to that when you apply for loans. That is very important.
So we do the same.
Pardon?
We basically do the same.
Yeah. You can figure out your interest on your own whenever you like sign up for a mortgage or take out your loans for student stuff.
I bet that's a great time to get your own math teacher.
Yeah. You know, it was so much fun figuring out how much I was going to owe. All right, last one, Half-Life, and then you're going to get your homework started on. Get excited. Thank you for your excitement.
I'm not excited.
All right, so Half-Life is the time it takes for 1/2 of a substance to decay or disintegrate. What's up?
I can't get the proof city guy.
You should already have that. It's from like 2 weeks ago. I need you to look for it, then come back later and get it. Thank you.
This should be easy because it was not a.
It is. All right, what is A? What do you think? A is the final amount. Which is the same thing, right? But this time we're not working with money. We're working with how something decays or dies or disintegrates or rots. Stuff like that.
Or gets absorbed.
Yeah. Alright, P is the initial amount.
Yeah.
And since it's half-life, it'll always be 0.05. And T stands for the number of half-lives in a given time period. Bless you. I don't know why you keep pointing at me, but I need you to stop. Thank you. Alright, so this says that the half-life of a certain antibiotic is 4 hours. So every 4 hours it dies. How much of a 45-gram dose will be left in your system after 2 days? So how many hours are in a day?
24.
Okay. And we have 2 days, correct? So what are we going to multiply 24 by? Times 2. But then what do we need to divide that by? How many hours does it, after how many hours does it disintegrate? 4. So you're going to do 24 times 2, and you're going to divide it by 4.
That'll be 12.
Yes. So 24 times 2 is 48. 48 divided by 4 is 12. Awesome. So that's what we're going to plug in for T. Does everybody understand? Okay. Now, we have A equals, what is our original amount of our thingy? Yes, 45. Times 0.05. And what's the exponent? What do we find? 12. Awesome. Plug it into your calculator. Do 0.5 to the 12th power and multiply it by 45. Yes.
I don't understand where you get the 24.
Okay, there's 24 hours in a day.
Yeah.
And it says 2 days. So it starts by telling us that we're decreasing, we're dying every 4 hours, right? So we have to convert, we're looking for 2 days, we have to convert days into hours. So we did 24 times 2, and then we have to divide it by 4 because every 4 hours is a half-life.
Is it?
I can't see that. Did you get 0.011?
Yep.
Yep. So you get 0.011 grams. Bum, 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 bum. You do 0.5, and you hit the, what kind of calculator do you have? I don't think there's a caret button on this one. 0.5. And
That's 48.
and then multiply by 45. Alright, so the last part, we're going to talk about the relationship between exponential growth and decay. First, do you think compound interest is a growth or a decay? Compound interest is a growth. So let's write that over here. Do you think that half-life is a growth or decay?
That's a decay.
That is a decay. What do you know about the graphs of exponential growth? Is the curve increasing or decreasing? Okay, so the graph is an increasing curve. What's the graph of a decay?
It's a decreasing curve.
Look at us go. If it's growing, it's adding. Awesome. So the formula is adding. What about on decay?
The formula is,
Good.
is subtract.
Good.
I should do that. But guess what?
You didn't. And here we are, having a pointless conversation. Will a decay ever reach 0?
No.
Nope. Oh, you can't see what I'm writing. I'm sorry, guys.
I saw it. You're telling us what you're reading.
I usually do that, but then y'all still say, I can't see it, I can't see it, I can't see it.
Let's answer.
I don't know.
Can a growth reach?
I wonder.
I
Nope,
wonder.
because it's growing.
Well, then wouldn't we put it in the middle?
A growth is going to be greater than 1. So a growth rate is greater than 1. Now, what do they have in common?
Formulas.
They both curve, okay? Okay. The formulas are well, we talked about the formulas here, so let's not add that to the middle, because one's adding, one's subtracting. Are the rates or the percentages ever negative? No, so rates are never negative. Sorry, are you not entertained? Do they both cross the y-axis?
No.
Yes, they do. They don't cross the x-axis, but they both have y-intercepts. We did that the other day, right, when we were matching them up? All right, so now I'm going to pass out your homework sheet for tonight.
Thank you.
While I'm passing it out, please clean up your